Hi everyone. In this video we're going to talk about connecting sensors to a Raspberry Pi. This is actually a series of videos. In this first video I'm going to talk about some basics, and then I'm going to talk about connecting a simple digital sensor like this touch sensor. In the next video I'm going to talk about connecting an output like this buzzer. And then in the third video I'm going to talk about the most complex one, which would be connecting an analog sensor like this one here to the Raspberry Pi. So let's talk about this one for right now. Now, it's totally possible with a simple sensor like this to connect it directly to the Raspberry Pi. You notice there's 3 pins on this sensor, and there's a number of pins on the Raspberry Pi right here. And to do that, you would use a set of jumper wires. And in this case, since both our sensor and the Raspberry Pi have pins, we would need jumper wires that have sockets on both ends. You can get them like this, or you can get them with pins on both ends, or with pins on one end and sockets on the other. And the important thing here is to know where you need to connect these. Now, if you look closely at this sensor, like most sensors, you will see that these pins are labeled in a particular way. And very often what you'll see on sensors is VCC, GND, and some sort of signal like D0 or IO or something like that. And all of these sensors have some combination of that type of marking. And what you should know for connecting them up to the Raspberry Pi is that the system works like this. VCC is power in. That's voltage to your sensor. And on a Raspberry Pi, that's almost always going to be 3.3 volts. Very few sensors will work on 5 volts. Unless you know for sure, go with 3.3. It's safer and you risk less damage to your Raspberry Pi or your sensor. And then GND goes to ground, and the pins on the Raspberry Pi will also be labeled GND. That's 0 volts. And then D0 or A0 are the output from the sensors, and that will be either digital or analog. And since we're focusing on just the digital sensor today, we'll worry about analog in a different video. All right, now what we're going to do with this sensor is, like I said, we could just take these jumper wires right here and we could connect the sensor. And we would take VCC and we would find our 3.3 volt pin on the Raspberry Pi. And we'd take GND and we'd find our ground or our GND pin on the Raspberry Pi, and we'd plug in one end of the jumper wire to each. And we could do that with our signal wire and find an appropriate GPIO pin on our Raspberry Pi. However, what we're going to do instead is we're going to make use of a breadboard to connect up our sensors. This is maybe a little much for one sensor, but once our circuits start becoming more complicated, this is really going to make life a lot easier for us. And a breadboard is simply a plastic board with lots of holes in it that we can go and poke our sensor into, and it will stay. And when we do that in this type of circuit, and that one's going to be straight up and down, so that would be a little bit difficult to see here. When we do that in this circuit, we're going to do that so that the sensor goes horizontally like this. And the reason for that is each of these rows of 5 holes are connected together inside. And so what that means is if I want to connect a wire, a jumper wire with a pin to this sensor, all I have to do is poke it in the same row as that pin is connected here. And so if you think about it, if I take the sensor and I turn it the other direction like this, what I'm doing is connecting all 3 of those pins together inside the breadboard, and that doesn't do me much good. It doesn't do me much good if they're all connected to the same thing. So I'm going to turn this sensor sideways like this, and then I'm going to take 3 jumper wires, and I'm going to connect them to this connector, which is then going to get plugged into my Raspberry Pi. And I will pause my screen here so that you don't have to watch the nitty-gritty of that, and I'll show you what I get when I'm done. And voila, there we go. We can see that those 3 wires are connected to the sensor, and they're connected to our Raspberry Pi interface right here. And what I did, and this will be a little bit hard to see on camera, is I made sure that this red wire goes from VCC over to 3.3 volts, and the black wire goes from GND to GND, and the yellow wire, so I'm following the same color code that I showed you in my example, in my listed just a little bit. Well, it was pretty common. Red for power, black for ground, and yellow or another bright color for the signal. I'm going from the output here into pin 23 on my Raspberry Pi interface. Why pin 23? Well, I don't know. I have lots of pins to choose from, and the program that I have written already uses pin 23, so I decided to be consistent and use that GPIO pin. GPIO stands for General Purpose I/O. And then I'm almost done. The last thing that I have to do is I have to plug this end of the cable right here into my Raspberry Pi and then power up my Raspberry Pi. Now this end of the cable on this particular connector, and I'm using a Raspberry Pi 3, so it might look a little bit different than yours. This connector plugs in like this, and the important thing is that you plug it in so that the connector goes away from the Raspberry Pi and doesn't go over the top. Your colors of your cables in this ribbon cable may be different, but if you plug it in so it goes outward from the Raspberry Pi instead of crossing over, you should be okay with this particular model. And I am going to then power up my Raspberry Pi, and we're also going to put that off screen. But you can see that there's the light that turns on the Raspberry Pi, and we get a light that turns on our interface board, and we get a light on the sensor. So things seem to be looking pretty good right now. Okay. Now let's talk about the software side of things. For our Raspberry Pi to be able to understand what's going on with that pin, it needs to have some code where we instruct it what is going on to be able to monitor that sensor. And I've written this code here in Python, and let's walk through a couple of the important things in here. Now you are welcome to take this code and copy and paste it or type it in exactly as you see here. Hopefully you know that in computer programming exactly matters, so pay attention to all the spaces and the commas and the parentheses and such. But let's hit some of the highlights. First of all, we are using a couple import statements up here because we need to bring in some additional instructions to the Raspberry Pi. One of them is the sleep function, and the other one is how to use those GPIO pins, those general purpose I/O pins. So the second thing then is that we need to do a little bit of setup. The first thing we need to do is tell the Raspberry Pi what pin numbers we're using. It turns out there's a couple different numbering systems. But then what we're going to do is we are going to tell it our input pin is going to be pin 23, just like I wired up. And we're going to tell it that that pin should be an input. Now it seems a little strange to say that because the word input is shown up all over the place here, but this is the actual line that tells them, hey, tells the Raspberry Pi, hey, read in on that pin instead of using it as an output. And then the actual business part of our program happens in this while true section down here. While true means that this part down here is going to repeat over and over and over and over again. It's going to repeat as long as true is true, which should be always. And we're going to check and see if that pin is true. And if so, we're going to print out to the screen that it's high, meaning that it has a high voltage. Otherwise, we're going to print that it's low, and then we're going to tell the Raspberry Pi to go to sleep for one second and read it over and over again. We call this polling. So just like a poll might call somebody up on a phone and say, what's your opinion on whatever, what we're going to do here is we're going to ask the pin, hey, are you high or low? And again, remember that means essentially on or off. It either has voltage on it, high, or it does not have voltage, low. So now what I want to do is I want to take that Python code and I want to upload it to my Raspberry Pi, and then I want to test it with my sensor. Before I go any further and make this breadboard more complicated, I want to see if this part is going to work. And I have already uploaded that already, and that code is here in my terminal. And what I can do inside my terminal is I can simply type Python 3 and then the name of the program that I want to run. In this case, I named it digital_in.py. And I can see that input 23 is being displayed as low all of the time. Well, let's see what happens then if we take our finger and we put our finger on the sensor here. Let me switch the view to the other way around. So we'll do this right here. Actually, that's a little harder because we're not readable down in that corner then. Let's do it this way. There we go. Okay, low, 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 and with my finger on it, see it changes to high. And when I take my finger off, it'll switch back to low. And we can see that this sensor is polling, or the Raspberry Pi is polling this sensor every second. All right, so we have our sensor working and we have it interfacing with a Python program on our Raspberry Pi. Let's go back and take a look at the code one more time because I want to show you where you can go with it from here with your code. So if we go back to this code right here, what I'd like to point out here is that if you want to do anything else with the value of the sensor, you can put it right under here, right underneath this print line. I'm going to put it in as a comment. So for example, if you need to send a message to another Raspberry Pi, maybe over a client-server connection, you could send a message right there. And if you need to send a message when the input is low, you can send another message right here. And it could be the same message or it could be a different message. You can send values. And of course, you can change this sleep number right here, and so it's faster or slower. And it's up to you to customize your program from here on out. Okay, so that is our first video in how we want to interface a basic digital sensor to our Raspberry Pi. In the next video, we're going to talk about interfacing an output to our Raspberry Pi.